Today we're going to review how to find distance on the coordinate plane. So to start out, we have our distance formula. Now the distance formula, some people write it in a couple different ways, but this is what we're going to use for today. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And each of these values come from our points, because in a coordinate plane, we have ordered pairs. So each point has an x and a y. And if it's from point 1, we call it x1 and y1. And if it's from point 2, we call it x2 and y2. And these are the values we end up substituting in. So x1 is our x1, x2 is our x2. So the first number in each ordered pair forms our x2 minus x1. Then our y1 is the y1 and the y2 is the y2. So the second number in each ordered pair is the y2, y1, and the y2. And I'm going to use this setup when I go to solve any question with the distance formula. Okay? So let's come down and do an example. It says find the distance between J and K. It could also say find the length of segment JK. So I'm going to use this same distance formula for this question. Only what I'm doing here is I'm replacing each of these values with what they are. So x2 comes from my second point. My second point here is K, and it is the x coordinate. So in this case, x2 is 5. Then I replace the x1 with the x coordinate from the first point. So let's see, we're looking for x1. So my first point is J and the x coordinate is 2. That is my x1. So now I'm going to fill in that for my x1. Now I need to repeat this process for my y2 and my y1. So y2 comes from the second point, and it's the second value. So y2 is going to be -4. And then I'm going to do it for y1. And y1 comes from the first point, and it's the second value. So y1 is -1. Once I have all of my values filled into my formula, I'm going to simplify it using order of operations. Remember, my order of operations is PEMDAS. So I'm going to start with what's in the parentheses. So the square root of, and I'm going to simplify what's inside each set of parentheses. So 5 minus 2 is 3. This gives me 3 squared plus. Then I'm going to simplify the next set of parentheses. -4 minus -1. That's the same thing as -4 plus 1, which is -3. So I get -3 squared. Okay, now I don't need to leave my square root quite as long. So I can shorten it if I want, but it really doesn't matter as long as it goes over everything. Okay, once I've done my parentheses, I can do my exponents. So 3 squared is 9, and -3 squared is 9. Then lastly, I can add, keeping everything underneath the square root, because that kind of acts like a set of parentheses, and I get the square root of 18. Here's where things are going to differ slightly based off what your teacher wants. If your teacher wants you to simplify the radical, you need to go in and simplify the radical. However, if your teacher doesn't want you to simplify the radical, you can simply plug this into a calculator and get a decimal. If I simplify the radical for this example, I should get 3 square root of 2, or if I'm looking for the decimal, I should get 4.2. It'll be higher than 4.2. It's 4.2426, but I'm going to round to the nearest tenth. So those are going to be my answers when I find the distance formula. The distance is simply a formula to plug into. So I'm identifying my x1, y1, my x2, y2, and I'm plugging it into this formula and then just simplifying. Remember, I can say that this is the distance, but I can also say that it is the length of the segment. And I should always end up with a positive answer at the end. And I need to be careful with my signs as I go through. So that is how you find the distance in the coordinate plane.